Hi guys, this is O-Level Chemistry, paper 11, June 2021, question 21. The Haber's process converts nitrogen and hydrogen into ammonia. Which row is correct? Change in condition. If the pressure is increased, the position of the equilibrium moves to the left. No, this is wrong. If the pressure is increased, the position of the equilibrium will move to the right because increase in pressure favors the side of the reaction with the lesser number of moles, and there are lesser number of moles of products than reactants, so equilibrium has to move towards the right, not towards the left. B, pressure is reduced, so a decrease in pressure will favor the equilibrium towards the side with the greater number of moles, so it should move towards the left. But here it is said that there is no change in the position of equilibrium, so this is also wrong. C, a catalyst is present. A presence of a catalyst does not affect the position of equilibrium. Here it is said that the position of equilibrium moves to the right, making this wrong as well. And the last one, catalyst is present, it does not change the position of equilibrium. So this is the correct reason for the position of equilibrium not moving, and the condition is addition of a catalyst which has no effect on the equilibrium position. Thus option D is the correct option for this question. Question 22. Which row shows the pH value of 0.1 mole per dm cube solutions of ammonia, hydrochloric acid, sodium chloride, and sodium hydroxide? So, out of these, NaCl is a neutral salt. A neutral salt will have a pH of 7. So, if just by looking at NaCl, we have eliminated options A and B. Now, the correct option would either be C or D. Now, let's look at the other values. So, for HCl is a strong acid. A strong acid has a low pH. So the options available are 1 and 11. 1 is a low pH and 11 is a high pH. 1 would be that of an acid, 11 would be that of a base. So HCl is the HCl with the pH 1 is the correct answer. This makes option C the correct answer. Option D has been eliminated, but we will look at the pH of the remaining two solutions as well. Now NaOH. NaOH is a strong base. A strong base will have a high pH. So we have a pH of 13, which is a high pH. So this is correct. And ammonia. Ammonia is a weak base. A weak base has a lower pH than a strong base. So if NaOH has a pH of 13, ammonia would have a pH lower than 13. Here in option C, it says 11. So this makes option C the correct option for this question. Question 23. The water in a lake is acidic and the fish are dying. The water in the lake needs to be neutralized. Which compound can be added in excess to neutralize the water in the lake? So we need to add a base, right? Which compound can be added in excess to neutralize the water in the lake? Now we also need to be careful that whatever we add does not affect the fish present, because if we carry out a very exothermic reaction, it would destroy the aquatic life. So now we have calcium carbonate. Now, calcium carbonate is a weak base. How do we know that? We have to understand how a salt is formed. The cation of the salt is from calcium. The anion of the salt is from, oh sorry, I said the cation from the salt is from the base, and the anion of the salt is from the acid. So in this case, calcium comes from calcium oxide, and CO3 comes from H2CO3, which is carbonic acid. So we have a strong base and a weak acid forming a weak base or a basic salt. So the strong nature is that of the base, so that strong nature will dominate the salt. In this way, phosphoric acid is a strong acid. We do not add strong acid. This will have no effect on the acid already present. Potassium hydroxide is a strong base. This will react very violently with the acid present and it will destroy aquatic life. And sodium nitrate. Now, sodium nitrate is a salt made from Na from NaOH. and NO3 from HNO3. Now, NaOH is a strong base. HNO3 is a strong acid. A strong acid and a strong base result in the formation of a neutral salt. And addition of a neutral salt will have no effect. So out of all of these, only A can be added because it is a basic salt or a weak base. It will gradually neutralize the acid present without harming the aquatic life. So option A is the correct option for this question. Question 24. Two incomplete statements about preparation of an insoluble salt are given. Dash can be used to prepare insoluble salts such as dash. Now let's fill these dash. So precipitation can be used to prepare an insoluble salt or titration. A titration is used to produce a soluble salt. So precipitation. So first blank eliminates option D. Now we continue such as dash. Now this dash should include a salt that is insoluble. So in A, we have barium nitrate. All nitrates are soluble. Option A eliminated. B, we have lead sulfate. C also lead sulfate. Lead sulfate is insoluble. So we continue on with options B and C. The salt is collected by dash. Now, how do you collect an insoluble salt? You collect an insoluble salt through filtration. You filter it out. The other option here is evaporation, which is wrong. So option C becomes correct, but we will continue on to the fourth blank, and it is then dash. So first we collect it by filtering as a residue, and then we wash and dry it. So all four statements that fill in these blanks are correct for option C, making option C the correct option for this question. Question 25. The Haber's process is used to make ammonia at a temperature of 400 degrees Celsius and a pressure of 20,000 kilopascals. The temperature is changed to 500 degrees Celsius and the pressure is kept the same. What will be the effect of this change on the production of ammonia? So now ammonia is formed in the Haber process with the reaction N2 plus 3H2 gives 2NH3. The forward reaction is exothermic and the backward reaction is endothermic. So what are we doing? We are increasing the temperature, and increase in temperature will favor the backward reaction because an increase in temperature favors the endothermic side of the reaction. And this question asks us what will be the effect of this change on the production of ammonia. Let's see. Option A, it is made at an increased rate and the position of the equilibrium moves to the left. Okay, position moves to the left is correct. It is made at an increased rate. This statement is also correct because we need to remember that an increase in temperature increases the rate of reaction. So option A is correct. Now let's move on to the other options and see why they are not correct. It is made at an increased rate. This part is correct, and the position of the equilibrium moves towards the right. This is wrong. Next, it is made at a decreased rate, wrong. And the position of the equilibrium moves to the left, this part is correct. And D, it is made at a decreased rate, wrong. And the position of the equilibrium moves towards the right, this is also wrong. So, in conclusion, option A is the correct option for this question. Question 26. Some properties which indicate the differences in elements are listed. Okay, metallic character, number of electron shells in an atom, number of protons in an atom, and total number of electrons in an atom. Okay, which two properties increases across a period of the period table? Okay, so we are moving along a period. So what happens to the metallic character? It decreases along a period. And we want to look at things that increase. So statement one or the property one is incorrect here. Two, number of electron shells in an atom. They stay the same. They do not increase or decrease in a period. Three, number of protons in an atom, they increase as we move along a period. So statement three or property three is correct. And four, total number of electrons in an atom, as we move along the period, the number of electrons present increases, but the shell number remains the same. So property number four is also correct. So properties three and four are correct, making option D the correct option for this question. Question 27. Elements X and Y combine to form an ionic compound. Atoms of X have more protons than atoms of Y. Okay. Atoms of Y have more valence electrons than atoms of X. Which statement is correct? Ions of X are negatively charged. Now, here they have said atoms of X have more protons than atoms of Y. Uh, now, the more protons can mean that it is present down the group, right? And atoms of Y have more valence electrons. If atoms of Y have more valence electrons, then Y would form a negative ion, which means X would form the positive ion. So ions of X are positively charged, not negatively charged. So A is incorrect. Next, atoms of X have more electron shells than atoms of Y. Now, it says that it has more protons. So more protons are present when the size of the atom is greater, and size of the atom is greater when it is found down the group. So if it is located down the group, it would have more electron shells than Y. So this option is correct. C, X and Y are in the same period of the periodic table. No, X is located below Y in a different period. X and Y are in the same group of the periodic table. That is impossible because X is forming a negative ion and Y is forming a positive ion. So this is incorrect as well. As a result, option B is the correct option for this question. Question 28. The elements in group 1 of the periodic table show trends in both their reactivities and their melting points. Rubidium is in group 1. Okay. Which statement about rubidium is correct? It has a higher melting point than potassium. Down the group, the melting point decreases. So it would have a lower melting point than potassium. So this statement is wrong. Next, it reacts with water to produce an acidic solution. A group 1 metal, when reacts with water, produces basic oxides. So the solution would be basic in nature, not acidic. This is wrong. It reacts with water to produce oxygen gas. When metals react with water, they produce hydrogen gas. This is also wrong. And it is more reactive than potassium. Reactivity decreases down the group. So reactivity increases down the group. So if reactivity increases, rubidium has to be more reactive than potassium. Statement D says it is more reactive than potassium. The statement is correct, making D the correct option for this question. Question 29. The properties of four substances are shown. Which substance is a metal? Okay. A. It conducts electricity when dissolved in water, but not when solid. This is the property of an ionic compound, not a metal. B. It has a high melting point and conducts heat when solid. Yes, metals have high melting point and they conduct heat when solid. So this is correct. C. It has a low melting point and is brittle. This is the property of a non-metal which will have a low melting point and will be brittle. So C is incorrect. D. It has a giant covalent structure with a high melting point. This is the property of a macromolecule, not a metal. So option B is the correct option for this question. Question 30. Group 1 elements and transition elements are metals. Student X suggests that group 1 elements are above hydrogen in the metal reactivity series, but that not all transition elements are. Student Y suggests that the densities of group 1 elements are lower than those of transition elements. Which students are correct? Okay. Now, group 1 metals are lithium, sodium, potassium, rubidium, cesium. So all of these are more reactive than hydrogen. Yes. So they are above hydrogen in the reactivity series. Whereas transition elements like titanium, vanadium, all are above hydrogen, whereas copper, silver, and gold are below hydrogen. So student X is correct. Now student Y says the densities of group 1 elements are lower than those of transition elements. Now the atoms of transition elements have a smaller size and a higher mass, so which makes their density is relatively high. So student Y is also correct. So we have both the students giving correct statements, making option A the correct option for this question.